Hey guys, welcome to day 1, topic 9 of our Olympiad series frameworks, and today we will be learning the Lagrange interpolation formula. So basically what it does is it allows us to construct a polynomial given any set of points. So it's like a machine that takes an input of these points and it constructs switches, what I call them, and we multiply that value by our y values, and that gives us a polynomial based off of these points. So just as a quick overview, this first switch is going to focus on this set of points, the second switch is going to focus on this set of points, and the third switch focuses on this set of points. So what it does is we're going to take a variable x and subtract all of the other x's from that x and do the same thing on the bottom. The only difference is that this x is the actual number, whereas the one on top is just the physical symbol x. So be sure to check out the online version with a real example. If that was a bit too general, please be sure to check out the online formula with a concrete example, which will make this a lot more clear. So let's take a look at the 1984 USA Math Olympiad question 5. So here it's telling us that p of x is a polynomial of degree 3n such that p of 0 is equal to p of 3 is equal to p of 3n is equal to 2. And p of 1 is equal to p of 4, is equal to 1. And these are equal to 0. So we can notice that there is going to be a cyclic pattern of repeating 2, 1, and 0 after every 3 steps. And basically what it's telling us here is we can take, since this is the x value, this is what we're plugging into the function, we can get our point 0, 2, because this is the x, that's the y. Now we have 1, 1, 1, and then 2, 0. Now repeating our pattern, what do you think our 3 is going to be as an output? If we loop back around, we find that it's just 2. It's going to be the same as the first value. So let's start by testing n equals 1, which is the smallest case, and our goal here is for p of 3n plus 1 equals 730. So 3 times 1 plus 1 is just 4. So our goal is to evaluate at x equals 4. And remember, this is just the test case for n equals 1, and then we'll work our way up. So let's construct our Lagrange switches that we saw here for each of our points. So for switch 1, we're going to hide this and only use these 2 points. For switch 2, we're going to hide 2 and use these 2 points. So that might seem a little similar to like taking the determinant. But basically, all we have to do is to find switch 1, we're going to take x minus, we're going to hide this, x minus 1 times x minus 2 times x minus 3, and divide by the same thing, just replacing the x for the actual value. So 0 minus 1 times 0 minus 2 times 0 minus 3. And that is our first switch. Now repeating the process here. For switch 2, we're going to hide our second points, and we're only going to use x minus 0 times x minus 2 times x minus 3 all over the same thing, but we're going to replace x with our actual value of x, which is 1. So I'm going to go ahead and do the rest. Perfect. So now all we have to do is plug in x equals 4 for all of our x's to find the numerical values. So the first one will give us 4 minus 1, that's 3, 4 minus 2 is 2, 4 minus 3 is 1. So we have 6 divided by negative 1 times negative 2 times negative 3 is negative 6, which equals negative 1. And doing the same thing for our other one, we are left with -1, 4, -6, and 4. Now, all that's left to do is to combine these switch values with our y values. So let's go ahead and do that. So our polynomial p of 4 is going to equal our y value times our switch, which is -1, plus our y value here times this switch, 4, plus our y value here, 0 times this switch, -6, and finally plus 2 times the here is 4. And that added together gives us a total of 10. Now remember, we were testing for n equals 1. So when n equals 1, x was 4. And we wanted p of 4 to equal 730. But our p of 4 is 10. That means that we're going to increment our n by 1. So we know that 1 doesn't work. So if we try all the cases for n and see what p of 3n plus 1 equals, we can find our value for n. So let me go do that real quick and give all the values. So using the exact same set of steps we used for n equals 1, we found n equals 2, n equals 3, and finally n equals 4, in which p of 3n plus 1 was 13, in which we found the answer is 730, which means that our n value must equal 4. Thank you so much for watching. I hope you found that helpful, and I will see you next time for topic 1.10, our last topic on day 1. Happy problem solving! Bye-bye!